Okay, people. So let's finish up this chapter. Our discussion about morphology and finite state transducer last time. I think good enough. Görebiliyor musunuz arkadan?
Kayıt başlattın mı?
Arkadan görebiliyor musunuz? Biraz şöyle yapsak mı acaba?
Senin boyu ne yapıyorsun hocam?
5 santim uzun. Aşağı yok yukarı. Okay, I started the recording. So the last time we talked about English morphology, and at the same time we are talking about Turkish morphology too. And at the end of this chapter, I am going to go over the remembers our Turkish morphology paper. We are going to look at it. What? Microphone. Okay, so let me, without doing much overview, actually, we talked about this. I mean, with the morphology, English morphology or Turkish morphology, there are inflectional morphology, çekim ekleri, and derivational, türetme. For Turkish, it is both complicated. For English, inflectional is very easy for the verbs. For the nouns, a little bit more complicated, but it is nowhere near as complicated as Turkish. We talked about that. And there are a few cases of English where we might have difficulty. For example, regular, irregular nouns and verbs. Okay, to make a noun plural, you add an s suffix at the end, but it doesn't happen. This rule is not valid for all the cases. For example, we don't say mouses, we say mice, etc. We know these.
I incorrect. Turkish why complex? Because Turkish use some rules,
Derivational,
derivation and inflection.
Yeah.
Because evdeyim. I think rule in location. I am for me.
Yeah.
I think is base rule and not complex.
It's not complex?
Isn't complex.
Well, it is more, well, I mean, being a complex or not complex is a relative thing, but it is definitely more complex than English. I mean, in English, for the inflectional, especially morphology, with a word like book, with a verb, what you say is just book, booking, booked, and books, that's it. Only 3 forms, but if you think about Turkish with a kitap word and all kinds of cases for nouns like the accusatives and nouns and etc., all kinds of possessive stuff, they all happen with the morphology. In English, you don't use morphology to, okay, you say her book, right? So 2 different words. In Turkish, you say kitabı. You change the word, okay? So the English, I am not saying that Turkish is more complicated than English, but Turkish handles most of the meanings and most of the syntax in the morphology side. English brings it to the level of syntax. So it uses more words, okay? There are more words in a given sentence in English, and their morphology is simpler than Turkish. One language is not more complicated or simpler than the other. The only thing is that their morphology side or the syntax side is a little bit different. So Turkish syntax, as we said, it is not much order dependent. That's why we are having difficulty finding Turkish grammar that explains everything. English grammar is more structured because they bring these kind of complications to their grammar side. Anyways, I mean, neither Turkish nor English is hand designed by people, right? They are natural phenomena, and we are not going to say this is better than the other. I mean, which one is better, elephant or the giraffe, right? I mean, both are just animals, like large animals. That's it. We can't just compare them. They are different. That's what we are saying. So you are saying that, I mean, the morphology side of Turkish is not complicated, but it's more complicated than, more involved than English. That's what we are saying. Okay, so let's move on. We already looked at these regulars and irregulars, and inflectional morphology, irregularities, that's why it is more difficult. And we looked at these, right? I mean, when it comes to inflectional morphology, English is complicated too, because starting from a word, you can move to other words, from verb to adjectives to nouns to verbs, and again, there are some exceptions here too. And if you define those kind of rules, and if you make such, okay, derivational rules for certain kinds of nouns or certain kinds of verbs, then everything is explainable, okay? Remember what we said last time, with a group number k of verbs, okay, it is acceptable group number k, whatever they are. But if you add this suffix to the end, I've, okay, we start with a verb and end with I've. Can you give me an example to make it an adjective? An adjective that ends with an I, but it starts with a verb.
Creative.
Who? What?
Creative.
But create, yeah, create, creative, yes, exactly. Create is a verb, so it belongs to this group K, and creative is an adjective. And creativeness becomes a noun, creatively becomes an adverb, etc. What is the difference between, oh, wow, it comes from there and there, right? Okay. So this is not easy. I mean, this is complicated too. But again, these are derivational rules. I mean, in a dictionary, when you look at it, create as an entry, creative has an entry, creativeness is as an entry, right? So those are separate words. In a dictionary, you have all of them listed. But kitap, kitabı, kitaplar, kitapları, kitaplarımız, etc. These are not different entries in a given dictionary. So that's what makes Turkish more complicated. Okay. Again, we are going to talk about this parsing thing. I mean, when we talked about, from the last chapter, when we say we are going to recognize something, we always use finite state machines. Finite state machine recognizes something. It says that, okay, if I can follow this, let's say create is a group K verb, okay. Create by itself is a acceptable string. And if I put the suffix at the end, it becomes an adjective and it is acceptable. Creativeness becomes another acceptable word and etc. That's okay. But we are not only concerned about accepting a word or not. We are also concerned about how we accept it, okay? What kind of path did I go through, okay? So that's called parsing. So giving a cats is okay. Cats is an English word, acceptable English word, okay? But what kind of structure does it have? It has a noun as a root of the word, and at the end there is a suffix, okay, morphological modification to make it plural. Okay, that's we are after actually. That's we are trying to find. This is called parsing. Of course, parsing includes recognition in it. Without recognizing that a word is in English or Turkish, you cannot do parsing, but parsing is more. Okay, parsing is more. You will say, okay, this is an English word and this is a parsed version of it. Okay, and one can go from this notation, a parsed notation, parsed version of a word, back to the surface form of it. Okay, and this is called generation. And both of them can be done using the same mechanism like we did in here. Okay, we started with create and we creative and creativeness or creatively, etc. So we can generate stuff too. So finite state transducers are very useful for doing this kind of generation and parsing. Finite state transducer is actually a finite state automata, finite state machine, but it deals with two tapes. One is an input tape, okay. The other one is for outputting stuff like extra symbols and transitions. Okay, when we read this surface form cats from the tape, on the other we write cat plus m plus pl is on the other one. So finite state transducer, this is my input surface form, this is the lexical form. When you output this, you did your morphological analysis of given word, surface form and the lexical form. Okay, it is not that easy all the time. You might say that whenever I see an S at the end, I put an PL. It doesn't work that way because sometimes because of the irregularities, okay, you don't say fox without saying E, right? Okay, you say foxes, okay, you say foxes. And similar thing, you don't say, what can you read this one? What is the surface form of this? Kitap plus N plus PSS plus 1 PS. What does it mean? Kitap. PSS means possessive, okay, singular, first person. Kitabım, right? Okay, possessive, singular, kitabım, right? It says kitabım, so what happens here, it says that you don't say kitapım, you say kitabım, right? Like there is an insertion of E there, it happens in English. In Turkish, P becomes B. We have these kind of rules. So it is not that trivial to go directly from the surface form to lexical form. we might have to follow some of the rules, and those rules have to be handled properly, and this kind of stuff happens for Turkish and English. Again, for the Turkish, number of rules are many, like more than 20. For English, it is a little bit less. Okay. We say kitabım, so it is like you always say like I am, but it doesn't happen that way. Sometimes we say, give me a Turkish word that ends with Kanunum. Yeah, kanunum, right? You don't say kanunim. So there is another rule there. We are looking at the compatibility of the vowels. Okay, we don't have such a thing in English or for German. Turkish is unique in kind of sense. We talked about this. Okay, applications of the morphological analysis. Okay, spelling correction, information retrieval again. Spelling correction or information retrieval is something that you does Microsoft Word, okay, does it work for the current kitabı? If I look for such a word on the web, let me, okay, tüm zamanların en iyi 35 kitabı. If I look for kitap, does it find? No, it doesn't find kitabı, see? It finds kitap, but it doesn't find kitabı. So this search mechanism doesn't know any morphological, and it doesn't do the morphological analysis of the word kitap. And I'm not sure if Word can do it. Do you think the Word can do it? Can it catch the root kitap out of a surface form of kitabı? I don't think so, right? It doesn't work. So spelling correction, for spelling correction, definitely we need the morphological analysis. That's the spelling correction. But for information retrieval, especially for Turkish, it is important to do this morphological analysis. If I am doing some information retrieval for this word, okay, kitap, anything that is derived out of this kitap should be returnable. That's why kitabı should be returnable too. Okay. So these are really very relevant kind of applications for the morphological analysis. Okay, good. So let's move on. Finite state transducers, they are very similar to finite state machines, but the thing is that they have one, remember, there is one input tape and there is an output tape. It says that if you see a C, then output a C. If you see an A, output an A. If you see a T, output a T. Okay, this one means plus and epsilon means read a plus and symbol on one tape and write nothing on the other tape. Epsilon means, remember the empty transitions? Okay, and this one read plus PL from one tape and write as to the other tape. It is not that important actually what is your input and what is output. You can change them. Okay, your output becomes input and input becomes output. So this is a very simple finite state transducer that does the surface form to lexical form, okay, parsing of this simple English word cats. Okay, so I am handling the plurality for English, you might say, but again, what am I gonna do with foxes? Okay, or passes, right? What am I gonna do? What am I gonna do with these kind of cases? Obviously, this finite state transducer will not work. I have to do something else. Okay, so but that will be our solution. Typically, we will read from one tape and write to other, but we can just switch them. That's what you say. Ambiguity, again, Remember, ambiguity is our main thing, main problem to address in all kinds of natural language processing analysis, including the morphology or phonology or syntax or semantics or whatever. And it's going to be like that, okay? Recall that in non-deterministic, that's why we like this non-deterministic recognition. Okay, remember that with the non-deterministic recognition, we have to follow all the paths to see if any of them will lead to an accept state. If more than one path will lead to an accept state, we have to list all of them. It is not enough anymore. It is not enough anymore to accept one string in one way. We should iterate over all possible ways of accepting a given string. And that means what? Our morphological analysis will be ambiguous. We won't know, okay? We won't know if it is, one way of parsing it that way or this way. Okay, we will not know it. And there are ways of dealing with the ambiguity, or sometimes we cannot solve it and we leave it ambiguous. Okay, so for example, this one has two kinds of morphological parsing. One is the book, okay, book plus and plus plural. That is the noun becoming a plural noun, books. The other one is book is verb, as is the third form of the verb book, right? So as a word as simple as books can be analyzed that way. Let me go to this Kemal Oflazer paper again. He has a very nice section about some examples. Yeah, these are good, yeah. Okay. Çocuklara, this is very good. I mean, as I said before many times, any NLP language, any natural language processing course should be given in two languages. I mean, everybody should know two languages, because the ambiguity in one language doesn't translate to other language. So in the other, if you try to give one sense of it, just use other language. For example, this one, çocukları, they are all çocukları, okay? The first meaning is çocuk, plural, third person possessive, çocukları, his, her children, okay? The second one is çocukları, accusative, children, okay? Accusative children. Show me the children, for example, okay? Show me the children. This one is their child, their child, right? That's the meaning, çocukları. So this is possessive, third person plural, right? And this is their children, çocukları, again, this is the same thing. Plural, their, third person plural and possessive, their children. It means four things, okay? And luckily for us, each meaning has a different corresponding English phrase, right? By the way, this one has an ambiguity in it, okay? I cannot translate this one as his children or her children, because it depends on the context of it. Again, the translation is ambiguous, but it is not the same ambiguity, it is something else.
Çocukları nasıl their child?
Excuse me?
How their child can be çocukları?
I have two people there, and I said they have a child, and I say their child.
Onların çocuğu, their child.
Oh, sorry. So there is a couple, man and woman. They have 5 children. When I talk about them, I will say çocukları, right?
Yeah, it's their children.
So it is their children.
Yes.
We will say Ahmet ve Ayşe Hanım'ın çocukları.
Their children, because
So it is their children.
they
Yeah.
have
But Ahmet and Ayşe Hanım has a single child, so it is çocukları. Ahmet ve Ayşe Hanım'ın çocukları. Ahmet ve Ayşe Hanım'ın çocukları Hüseyin geldi. Hüseyin is a single child. They have a single child, so it is çocukları.
Not çocuğu.
Çocukları yok ya, Ahmet'le Ayşe Hanım'ın çocukları demez misiniz? Bu kim?
Bir tanesi.
Çocuğu demez, çocukları ya. Çocukları dersiniz.
Çocukları da denir. Zaten
Doğrusu çocukları.
Öyle mi?
Türkçe bilmiyorsunuz ya.
Hocam ben bilmeyebilirim.
Öğren. Maybe we don't say it always çocukları, çocuğu. But I think çocukları is better. Right? Because I mean, then how do you make the distinction between Ahmet Bey'in çocuğu, Ahmet ve Ayşe Hanım'ın çocukları? They are the same thing. Well, I mean in Turkish it is yeah. That's why I say çocukları, right? This one. Ahmet Bey'in çocukları ve onların. Anyway, it is ambiguous already. Don't make it more ambiguous, but this is true. That's one way of saying that. Okay. Yeah. I am not saying that Ahmet ve Ayşe Hanım'ın çocukları, if there is a single child, okay? It should be said this way, but this is accepted. Anyway, other stuff like, for example, alınmış. This is even more ambiguous. Why? Because I am taking this. There is this adjective al, right? Kırmızı. And there is this noun alın, forehead, right? So I think these are all. And there is this alınmak, right? And there is a verb form of it. So this is al, alın. And this is, what is this? Alınmış. What can you take on? Oh, okay. Alınmış mal kiralanmıştan iyidir, for example, right? That's alınmış. I don't know how we are dealing with this kind of. Are you still saying that Turkish is easy in terms of morphology? Is that what you were saying, right? So you still argue that. How do you teach this to somebody? I don't know. I mean, it's not an easy language to learn, especially as your second language. I mean, when you talk about it, you understand it, but trying to teach it using these kind of rules, that's one of our mistakes, okay? We try to teach and learn other languages using these kind of rules. Language is not learned that way. Language is not spoken that way, okay? We learn it first and later we talk about this stuff. But they just follow just the opposite way of doing it. They teach us the grammar first. That's what they do. And they expect us to talk, and it doesn't happen that way. I mean, as people, as humans, we learn it somehow by talking and by listening to other people and like trying. Later we make sense of this kind of stuff. Okay, so ambiguity is always there, and whatever mechanism we are using, it should output all of those possibilities. I mean, it is not enough to say, I accept it, alınmış. Okay, this is a Turkish word, okay? No, you are going to tell me, alınmış is accepted, but there are how many ways of accepting it? There are 1, 2, 3, 4, 5, 6, 7 ways of accepting it. Okay? Only with this kind of morphological analysis I can do the later phases of the natural language processing, such as the syntactic analysis and semantic analysis, and later maybe machine translation.
I think for morphological analysis, because we product the derivation base rules.
Yeah. So English has rules too. English has rules too. I mean, you follow the rules, and some, yeah, you might say that there are exceptions. Exceptions are exceptions. In Turkish, there are exceptions too. We don't realize it. I mean, you are not talking your mother tongue Turkish using these rules, right? You even, most of us don't know the rules. We forgot about rules, but we speak it, right? I mean, when we started our primary school, everybody, I mean, any 7-year-old kid, when I say alınmış, alınmış, alınmış, alınmış, he or she can understand what each of those meanings are, right? Without knowing any of this stuff. So we don't follow the rules, we speak it. So a language has rules or more rules or less rules. It doesn't mean much because we don't follow these rules. These rules are invented by that guy, Kemal Afrazer, or somebody that is cited. Okay, nobody designed Turkish, nobody designed English. These languages were natural as occurred. They have their evolution. They are starting from some other language maybe. We don't know how they came, but this is a language that we talk, that we use, and we don't have to follow these rules. Maybe somebody will come up with a smaller set of rules, three-level rule base that will be more easy for Turkish. We don't know. My point is, you are saying that Turkish is easy because it's a rule-based language. I am saying that no, it is not. It doesn't have to be a rule-based language. Every language can be made a rule-based language, but nobody uses the rules when they talk. The way we talk is the same, English or Turkish. Okay, we learn it somehow, and we talk from the top of our heads. Okay. So we talk about this. Again, the same thing. You understand this, huh? Unionizable, I can parse it two ways. Unionizable or unionizable. Remember, ion is a verb, okay? On is a prefix, not suffix. Anyways, okay, ambiguity still, there are many ways to deal with the ambiguity. In this chapter, we are not going to deal with the ambiguity. We will show that there are ambiguous forms of recognizing a word. Okay, so let's come back to English and let's see some of the complicated stuff. For example, that dropping of this cat, dogs. These are simple, but fox and foxes are a little bit different. Okay, so to deal with this kind of stuff, to make it a little bit easier, we are going to do this multi-tape machine. Okay, we are going to introduce another tape, an intermediate tape. It will make a pre-analysis of the surface form. It will give us an intermediate analysis results, and from the intermediate analysis results, we are going to get the final parsing results. It's going to be something like this. So this is the surface form. This is the form. This is the form that we see on a paper. Okay, foxes. This will be our intermediate form. It says that there is an "s" suffix at the end of this noun fox, and this is the end of the word. And then from intermediate to lexical, we say that, okay, it's a noun and it's in the plural form. Well, you might say that, I mean, what is useful about this? I don't know. Well, you are going to see that in English, you don't have a single E drop rule or insertion of the E rule, okay? There are other rules, okay? For example, there is a Y rule, okay? When you say fly, it becomes flies, right? Flies. Okay? Insertion of IE and dropping of that Y thing. So there are a few cases like this for English. For Turkish, it is more. Okay, and we are going to see them in a few minutes in that paper. Okay, let's see how we can, going from one intermediate to lexical is easier. All you say is, okay, this is plural. Okay, let's do that. Okay, so we are going from lexical to intermediate or intermediate to lexical, doesn't matter. Intermediate lexical, so we are dealing with this part only now. So that's it. Letter by letter, fox or cat, okay. So I see an F, produce an F, XX, okay. And then without seeing anything, produce a plus N, and at the end of the word produce a singular or had as a sharp sign, produce plural. If the word is not a regular word, then I have to follow these. These are singular and plural. This is not a big thing, okay? So I did this only for what? 3 words: fox, cat, and goose. That's it. I can do this for all kinds of words for the plural analysis. So this is intermediate to lexical. How about surface to intermediate? Okay, here is one example. This is a finite state transducer that add an E rule or drop an E rule, depending on you are going to surface to intermediate or intermediate to lexical. A little bit more complicated. So it says that, okay, this one says that whatever letter you are reading, just read it and output it. Doesn't matter what you are doing, okay? Read and output it. But if you read an Z, S, or X, okay, come to this Q1. Q1 is an except state, okay? Q is an except state. So if somebody says fox, okay, read F, read O, output F, output O, and when you read X, come to Q1, and I am done, okay? So it will be like this, okay? Just a fox, F-O-X. So I'm going to produce an F-O-X and a sharp sign. That will be it, okay? Here I am going to, no, it just, yeah. Even, see, this is a non-deterministic machine. I think for the F-O-X, I will stay at Q0. Right, Q0, Q0, Q0. At the end, I am going to produce an sharp sign. That's it. But when it comes to foxes, F-O-X comes here, okay? Remember what I'm going to produce? I am going to produce fox, right? It's going to be like this. I am going to produce this. F-O here, X is here. Then without reading anything, produce the head sign, and then what? Drop the E, don't produce anything, and S will be at the end, produce it. When we come here at the end, this is not a final state, produce this one and come to this one and final state. Okay, so if I do this, foxes is my input, F-O-X here, okay, produce this one without reading anything, read this E, don't produce anything, then read an S and produce an S, and go to the other side. So it looks like this Q0, Q1, Q2, Q3, and Q4 is okay. How about this Q5? I don't want to get confused about stuff like, for example, like the same thing can happen with a word ending with an S, right? So, for example, tell me a word that ends with an S. What? Pet? Glass? Well, glass is not a good one. I mean, then give me a word that ends with a single S. Who's talking? Trousers. but it ends with an S, that S is a plural S. Just give me a, it should be a S, it shouldn't be a plural, because if it's plural, then I have to do this stuff at the S. What I am saying is, a word can end with two S's or two X's. In that case, I should be doing this over and over again. Understand?
Sir, is deletions okay?
What do you mean deletion?
But
What?
the word delicious, you said you want something single S.
What word?
Delicious.
Deletion?
Delicious.
Delicious. Delicious. Well, it is not a noun, right?
No,
It's an adjective. Well, in that case, really, we can do it, but yeah, let's say delicious is like a noun, something like. Again, it is ending with two S's. Okay. Well, anyway, okay, forget about it. These rules are good for words that are ending with okay, two S's. For the first S, we should not look for an E, okay? After the second S, we should look for an E. That's what we are saying. So they say that after the S, if we keep seeing this S or Z, we should continue, and sometimes we produce this one and we produce that as, how about, I don't understand this part. I don't understand that part. This part, I don't know. I mean, those are some of the cases. I don't understand this part. After outputting this head sign, I think there is something more going on. I don't understand this Q5, but I forgot. But this is what we need for now. So this is just a finite state transducer that will handle this E rule. In English, we have the E rule, we have the Y rule. What else? Do we have any other rules? E drop rule. Drop E spelling rule. Okay. Oh, this is a different thing. Writable. Is that dropping E with ing? Okay, this is another rule, right? Right. So you don't say write, you don't put ing at the end. You drop this one, right? Ing later. So you just drop this E at the end and put ing at the end. So maybe we'll need another finite state transducer for that dropping of E. In this case, it's not going to be S, it's going to be ing, right? So another rule, another finite state transducer. So we will have many finite state transducers between this surface and the intermediate tapes. The nice thing is, any of them can work anytime, but we don't have to think about the others while we are working with this one. While we are working with this one, we don't have to think about that dropping of E rule for the ing case, right? It can be another machine. And this is what's happening. Fox, this is, remember, 0, 0. Okay, at the beginning I am 0, after F I am 0, after O I am 0, after X I am 1, then to the E with the empty transition output head sign, then E, but I don't output anything, then S, I output S, and at the end I go to 0 and output this one. Once I have this, I can run my second lexical to intermediate level transducer. Where did that go? This one. Okay. My application has crashed. So where am I going with this stuff? I am going this stuff. I am going to this direction. I am going to give you this overall scheme. Say that, okay? Write lots of orthographic rules. This will handle dropping of E sound when there is a plurality involved. The finite state transducer 2, okay, will involve dropping of the E sound when there is an ing. Then there is an ly rule, and etc. There are n orthographic rules. We call them orthographic rules. They are all separate, and they are all defined in our linguistic books and linguistic rule literature. We put them together. So how do we put them? I don't design the whole thing. I design these finite state transducer one by one. Then I take the union of these, right? Remember how we take the union of these? Remember that? I think it was the last thing that I showed you in our finite state machine chapter. It was like this. It was like this, right? So this finite state automata recognizes one string, one type of string, sheep language. This one recognizes chicken language, but this whole thing recognizes both chicken language and the sheep language. So this finite state transducer will recognize the dropping of the E sound for the plural case. This one will do the dropping of the E sound for the ing case, but this whole thing will recognize both of them at the same time. As a computational linguistic researcher, all I do is just design this one and this one and other one and other one and put them together. Okay, put them together and then we'll call them, okay, our set of orthographic rules, and this will handle from the surface form to intermediate form stuff. The rest of them will be a one large lexicon finite state transducer. This will talk about I can add more abstract level stuff. I can add an s at the end of a word, right? I can add an ing at the end of a word without, I mean, it's going to be going or writing or something. After go, I don't drop anything. I don't add anything. But after write, I have to drop e, right? After a, I do something, right? I cannot think of any word that ends with an a, but they all have their own behavior. Okay, so this will be our overall scheme of putting together a morphological analyzer for any language. Come up with your orthographic rules and put your lexicon finite state transducer later. Okay, so doesn't do anything to inputs. Okay, we talked about this. Lexical level, the intermediate forms. Okay, that will be the second, and these are overall. Okay, so let's look at this one, and after that we will be done. Okay, let me get rid of this. Okay, so once you come up with such a orthographic rule set and the lexicon finite state transducer, okay, you put them together. Okay, take the union of all of them, all of those rules, and then compose these two finite state transducers, and this will be a one large finite state transducer. When you look at it as a human being, I won't understand anything at all, but it is something the machine knows. Okay, all I know is I designed this n plus 1 or maybe 2 finite state transducers, and there will be one large finite state transducer the ND recognized can run. Okay, we looked at this one. Remember how we take the union of the stuff? We already know, but we don't know how to do this composition. Okay, remember this? You guys remember this notation? There is a function f, there is a function g, right? And when we do FGX, we call this composition, right? F of G. You guys remember this? From high school, middle school, whatever? Okay, or maybe from your discrete classes, yeah, you know that. It's the same thing. Composition of two finite state transducers. And how am I gonna do that? Composition is going to be like this. These are the rules. Let's say I like to compose these two rules. Rule number one says that, okay, if my current state is XA, if my input is I will output as C, and my next state will be XB, okay? And the second finite state transducer says that if my current state is YA, if my input is C and output will be O, and my next state will be YB, then if I compose these two, this one inputs as C, this one outputs as C, this one inputs as C. I'll say that I am going to take your current state as XA, YA, these two, and your next state will be XB, YB, like this one. And if you input an I, you are going to output an O. So I am going to get rid of this intermediate case. That's called the composition. So it means what? In my finite state transducer 1, if I have n states, if I have finite state transducer, it has, let's say, m states, then my composed case will have n times m states because I am composing them. It will be much larger, like, it will be much larger. It's like square times larger of these two. But it will be composition of these two finite state transducers. Okay? Good. So again, to repeat, this is what we do. I design these rules, insertion of E rules, insertion, the removal of the I rule and the ing rule, and etc. N of them, and I design this one too. I mean, the things can get plural suffixes or the ing suffixes and etc. This is more abstract level, and put them together, and now I have a finite state transducer that works for all the words, okay? And it's going to give me lots of parsings, ambiguous parsings for the given word, okay? And as you remember, for Turkish, there is this online site available, and is it okay? Okay, what was the çocukları? Right? Analyze it. This one has lots of rules. Some of them are contradicting, but remember, I think çocukları has how many meanings? How many morphological parses? What? 7 çocukları? Really? Okay. Çocuk. No, 1, 2, 3, 4. Alınmışız that. 1, 2, 3, 4. Well, this one is producing many more. Some of them are not true, but okay. So this is noun, plural, third person singular. Çocukları, okay. Ahmet'le Ali Bey'in
Hocam aslında yerine göre
çocukları.
değişiyor. Şimdi mesela cümlenin sonundaysa bu onların çocuğu denir.
Are you talking in Turkish?
We speak in English, sorry. This is their child. Bu onların çocuğu. We say it like that. But if we want to use it as tümleç, we should say the plural form.
So what's your point?
Ya onların çocukları geldi. Doğru. Onların çocuğu geldi. Yanlış.
Well, exactly. That's you are talking about context, and that's what we are saying.
Suffixes change based on, also they change meaning because the plural onların çocukları refers to onlar, but bu onların çocuk.
No, the meaning doesn't change. The meaning is exactly çocuk. It is child, right?
But the parsing.
Yeah, the morphological parsing changes. That's what we are saying. Without looking at the context, without looking at the whole sentence and sometimes paragraph, sometimes the whole document, we cannot know which parsing, morphological parsing of this çocukları is correct. Okay? So, as the final output of our morphological answer, okay, morphological analysis, we cannot say that this is true, this is the one that you should pick. All we can do is we list all of them, and it is up to the consequent analysis steps to make that decision. How am I going to make that decision? By looking at the syntax, by looking at the semantics, by looking at the context or discourse or whatever, okay? At this phase, I don't have sentences, okay? I have only words, because morphology is one of the earliest steps of doing any natural language processing. We didn't talk about the grammar yet. We didn't talk about the meanings of words yet. Okay. I mean, I like to spend more time on this morphology because, as I said, Turkish is very rich in terms of morphology, both inflectional and derivational. As the book says, it is really the morphological analysis of the whole languages, all the languages. Of course, it is valid. All the languages has to do it more, but Turkish is at the end of the whole spectrum of the morphological languages. It is at the one end. It is one of the most complicated, more involved languages of all the human languages.
So even if it doesn't make it plural, we still parse it as if it makes it plural.
At the beginning, when we do the analysis, okay, we do the analysis of the words one by one. Since we did not look at the syntax analysis of the sentence or the semantic analysis of the sentence, we don't. It's like a pipeline, okay? First you take your words, do the. Why don't I? Okay, that's a good question. Let me go to the beginning of the semester and remember what we said about the whole categories of linguistic knowledge. Phonology is the science of the sounds. We kind of ignore it. Then we have the morphology. Morphology is, we looked at the structure of the words, okay? How the words are formed. We first start from morphology, then syntax. Syntax is how the words come together. Okay, those are the rules. Semantics is the meaning of the words makes a difference. Why? Because a word can mean more than one thing, and which meaning we mean is an issue. It is called semantics. Pragmatics is the context, okay? Under what context I am saying this, and it's going to give me some new meanings. And discourse is the expected thing in a social environment, you might say. If I am in a social position, like yourself is talking to me as a student, okay, the way you talk, the way you choose your sentences and your words is different than you talk to somebody else. So these are all levels of natural language processing and analysis, and we are still at this phase. We did not look at any syntax, semantics, pragmatics, or discourse yet. Okay? So basically what you are saying is true. If we look at the semantics of those words or the pragmatics of it, of course, I mean only one of them, okay? I mean only one of them, but we did not look at them. And remember how we solved the ambiguity? How we solved the ambiguity? Where was it? One of the rules is okay? One of the rules is don't do anything, just ignore it, okay? I will keep it as it is. Maybe it will be sorted automatically. The other one is I parsed it in 4 different ways, but most likely it is going to be this because out of all the examples, this is the most common one. And sometimes we say that, okay, sometimes it's like a pipeline. Somebody will solve it for me. Okay, I am going to just output these results. Those are the steps that we are going to follow. Okay, so after the composition and this, I am way out of my time. Let's take some break. After the break, we are going to look at this paper in a more careful way. And after that, I am going to start looking at language modeling, more syntax, maybe semantics. Efendim?
Kimseleri göremedim. O yüzden.
Verdim ya. Yani dersten hemen önce verdim. Nereye bak? Bugün mü? Ha, bugün verdim. Tamam.
Yoklama nerede hocam?
Çantamda.
Hiç dağıtmadınız değil mi yani?
Ne kadar sürer diye sordu da. 5'leri falan. Yani o isterse çıkabiliriz. Onu ilk yaparız. Tamam. O zaman onu çıkar. Öyle. O zaman çarpma değil mi? Saat kaç şu an? Bir dakika daha erken değil mi? 14.36 da. Diğer ders 3.30'a bitse. Derse gitmeyeceksiniz. Ama şimdi erken gidersek çok erken olur. Orada şey yapamayız. Okay, dersi bölmemek için demiştim öyle abi. Tamam, dersi bölmeyin. O zaman buralarda takılalım. Şey yapalım. O zaman arayayım. 20 gibi falan konuşalım. Tamam, ben de arayayım o zaman. Tamam. Çay varmış.
kelimenin bağlamına bağlı olarak çeşitli anlamlara çeşitli anlamlar yapmış. Ben bütün o projeyi biraz Python kullanarak yapmıştım. O kadar zorlanmadım. Aslında bu artık şey oluyor bir süre sonra. Şimdi derdin neyse yazıyorsun, şöyle oluyormuş, böyle oluyormuş. Biraz zaman alıyor ama. Hangi ödül?
Hocam ikinci arayı tek verecek misiniz?
Efendim?
İkinci arı verilecek mi?
Evet.
Tamam. Ben ikinci arada gitmem gerekebilir de şimdi
yok.
imza atmayayım ona göre.
Aklını yapmıyorsun ya.
Biraz önce
Tamam başka bir yere falan dur.
bir de vizeyi 7 Kasım'da olacak diye silabüse yazmıştınız.
Efendim?
Vizeyi 7 Kasım'da olacak diye silabüse yazmıştınız.
Hafta 7 Kasım mı?
Haftaya değil ondan sonraki
Tamam
haftaya.
haftaya konuşuruz. Nasıl buradan başlayalım? Burada oturuyor mu? Kahve mi unutmuşum? Neyse. Okay, so that's the end of this chapter. Let's look at this paper again. Where is my paper? Yeah, this Turkish Morphology paper. Well, it does exactly what we said. Okay, two-level description of Turkish morphology. Again, surface to intermediate level, intermediate to lexical form. Okay, so we are going to have lots of rules about the surface to intermediate level. Then we are going to have one or two, I think two finite state transducers from intermediate to lexical form. And this one says that, okay, they had used 23,000 Turkish root words, and we have 22 two-level rules, okay? So there are 22, remember these? Remember these, yeah, there are n of them, there are 22 of them, okay? 22 of them in that case, and they have described all these rules one by one. Okay. In Turkish, there is vowel harmony, and for that, we had to embed this vowel harmony in our ortho. You remember those rules here? These are the orthographic rules that we had. Okay, we are going to embed all these Turkish vowel harmony into these, and here are the two-level morphology, the first level, okay? That's the notation. Remember A, B, okay? Our transducer, when you see A, output a B. But you are going to do this in this context, okay? Left context and right context. If this happens before and if this happens after, then you are going to do this. This is the context restriction rule, which states that a lexical A can be realized as a surface B only in the given left context and right context, but necessarily always. I mean, A and B can happen, CA, then produce B, can happen with these two contexts, okay, left and right, but it can happen in other cases too. And there are other types of definitions, okay, and these are, okay, remember this one? So there are 22 of them, this guy. So surface tape to, well, it says lexical tape, but it goes through the intermediate level first. This is the Turkish vowels, okay. This is how we produce these vowels. There are 8 of them. Front means that, okay, round means that the roundness of your lips. U, okay. U, Ü, O, Ö, they are all lip round vowels. But E, I, E, A, they are not round, okay? Your lips are not round. High means that, for example, just everybody do this. Say U, O, U, O, U, O, U, O. What is the difference between U and O in terms of your tongue position? U, O. It is U, O, U. Just do it. Say U and O and try to tell me the difference between those two sounds in terms of your tongue motion. U, O. Both of them, your lips are rounded. U and O. Then both of them, okay. Both of them, your back of your tongue is in U, it is high, then O, U, O. Try to imagine how your tongue behaves. In one of them it is high, the other one is low, okay? The same thing with the not rounded lips, and A, A. Okay, your tongue is doing this high and low thing, okay? Are you doing this raising your tongue with the front of your tongue or the back of your tongue, okay? Ü and Ü, Ü. So with the Ü, your front of your tongue is high, right? Ü, your front of your tongue becomes low. So these are some of the phonetic features of our language. I think I showed you last time. These are not all the vowels that our tongue and vocal tract can produce. IPA chart, where is IPA chart? I think I showed you last time. Yeah, this is a very nice chart of the vowels. So these are how many? 1, 2, 3, 6, 12, 24, around 30 sounds human vocal tract can do, the vowels. And these are the vowels. Let me see. Does it work? Can I click on it? Yeah. How come? Oh, is that? Why it is not? Headphones? I don't have headphones. Speakers. Okay. Okay. So the closed lips, open lips, U. This is A. And I think in this part, back side of your tongue is high. Ooh. This is ah. This is another ah. I mean, in Turkish, we don't have any distinction between these two. I think our ah is closer to this one, right? There is another ah here. Maybe this one, I don't know. Between this. Which one? I think this one is our. This one? Yeah. So our E is this? Maybe this one? I'm not a phonologist, okay? I don't know how to produce any of those. What I am trying to say is that there are many vowels that the human vocal tract produces, and it wouldn't be true to say that we are using only 8 of them. No, in Turkish, in modern day Turkish, I think we have more than 8. How many vowel sounds do we have? Okay, how many vowels in Turkish? 8 vowels it says, but it is not correct. Sounds maybe. Well, vowels in the alphabet. How many sounds in Turkish? Let's do that. 28 phonemes. I forgot. We have, I mean, our number of sounds is more than the, okay. These are the stuff. Do you guys see any numbers? Okay, 1, 2, 3, 4. Well, these are, okay. See this one. This one is our A. Where is IPA chart? This one. It looks like this one is our A. And E is here. Our O is here. So it looks like our vowels are like this. How about the consonants? I am not going to find it, I guess. So you read it yourself. I always learn about it, but I forgot later. But the number of sounds that we produce in Turkish is more than the number of alphabet letters that we have. And these are some of the consonants, or all the consonants. Let me play some of them. For example, this one.
Sa, asa. Sa, asa. Za, aza.
It looks like our S and our Z. How about this?
Sha, asha. Ja, aja. Sha, asha.
What's the difference between this one?
Sha, asha. Sha, asha.
So those are two different.
Sha, asha.
Most of the
Sha,
time,
asha.
we use both of them, but it depends on the word itself. Okay, but we don't realize that we are using two different sounds. We don't realize it. Anyway, if we go back to our paper, okay, it talks about the vowels. Then these are the consonants, okay, where they are located. And now these are some of the groupings of those. So we are going to call them as C consonants. These are the surface vowels, 8 of them. These are the lexical vowels. Okay, there's any capital letter represents some kind of a group. Okay, small case letter represents the letter itself. Capital case represents something else. For example, this H represents this. I, U, and U. This H represents it. A represents A ya da E. And these will represent uzun A, uzun U, etc. So in Turkish, for example, yeah, Alkol, we don't say alcohol, we say alcohol. We don't say gol, we say gol, right? So those are two different O's. And we make this distinction. Again, we are going to call all of those O's as O hat or A hat. Okay, this as represents a lexical S which never gets deleted during affixation. K is for what? A root final lexical K, konuk, konuğu, remember that, okay? Sometimes it becomes a yumuşak G, yumuşaması. Okay, D is doing the same thing again. Some of the rules, and for each rule, now we have these. Okay, when you see this A produce an capital A, remember, I am going to represent both A ve E. I am going to represent them with A. I am going to represent all of these U, Ü, I with capital H, etc. Okay. Sometimes this H vowel sometimes is deleted, depending on the, okay. So our possessive suffix, iyilik eki, you drop this I when the word ends with a vowel, masam. You don't say masaım, you say masam, okay? So this one is dropping, and that's how you get it back. And sometimes kapıyor, kapağıyor, you drop both I and again, kapıyor. So these are the rules. They are going to list all of these rules. Where is our rule for the yumuşama? Evinin, evinin, kapının, we don't say evinin, we say evin. Dropping of N. Okay, this is DT stuff. Kitap, kitab. Okay. This is BD stuff, PT. And this is JC stuff. What happens? It says produce all of these. Oh, drop it. Okay. And it's the same thing. Haraç, haraççı, haraç. What's going on? Yeah. We don't say haraççı, we say haraççı, right? So this J becomes Ç. Okay, lists all of these 22 rules, and this will be our 22 orthographic rules of Turkish. And after that, after we get the intermediate form of the surface form, we give to, okay, these are our lexicon, all of the words. What did they say? It's a 23,000 words, root words, okay? And we produce these finite state machines or finite transducer for the nouns and the verbs, and these are the rules, okay? So these are the nouns. Remember this L-I-K, I-C-I, C-I-K. So look, c, cık, etc. Okay. Kitap, kitaplık, kitap, kitapçı. Noun becomes another noun. Okay. Or kitap, kitaplaş. Right? So it is becoming a verb. Kitap, kitaplan. Kitap, kitapla. It is becoming a verbal root. And then we have our plural suffixes, and etc. It becomes plural. Then we have our possessives. In some cases, the things got complicated, so they invented this case 1, case 2, case 3 stuff. And let's try to see what this case 1 is. Kitaplar, what is this? S. What?
Paylaşmak.
What? This is lar. This is plural. Kitaplar or zero. Okay. Kitap. Kitapsı. Kitabı. Kitabı. Kitabım. Okay. Kitabım. Kitabıma. Okay. This is e hali. Okay. Accusative case, I guess. Kitabıma. Kitabımda. Then the relative kitabımdaki. And if I go there, it becomes another plural. Kitabımdakiler. Okay. If I go there, how do I end this? Where are the end cases? From the relative, I go back to case 2. Kitabımdaki, kitabımdakindeki. Kitabımdakindeki. Okay. Ler. And then how do I end it? Okay. So it looks like all those rectangular boxes, they are all final states. So these are all for the nouns. How about this one? Kitap, 0, 0, 0. 0 means epsilon. Okay. Kitap, kitabıyken, temporal adverb. Etc. So it is again, it takes some time to grasp the whole thing, but our final states, these are the final states too. So when you follow all these, and when you do your parsing, you get stuff like this. Okay, you get stuff like the stuff. Okay. Let's go back to that one later. Let's see the verb cases later. Okay, first, the first final state machine was for the nouns. Now it is for the verbs. Verbal root. Then, okay, koş, koşan, reflexive. Koşuş, koşuştur, koşuştur, koşuşturulmak. Okay. Koşuşturulan. Oh, okay, plus koşuşturulma, etc. So each of them is giving us a path. It looks like it's, again, these are all for inflectional morphology. Follow every path. Every time you pass through one of these links, you are going to output one of these lexical forms of your analyzed word. And we say that, what is the difference between this one and the other one? This is the verbal root, and verbal root again, system root, same thing. Oh, okay, it is a continuation of it. So it comes from the nominal root, a verbal stem. Take this one and continue. Okay? So two big finite state transducers, one for the nouns, one for the verbs, and 22 first level rules. If you put them together, you are going to, well, by the way, special cases and exceptions. Sometimes I cannot explain the whole Turkish words using all of these words, so I need to make some exceptions. Okay? So the either power of the finite state machines are not enough to represent all of those, or it's going to make our finite state machines a lot more complicated. So I am going to make some exceptions. It looks like adverbial formations indicating temporal and spatial relative positions can be directly formed with ki suffix. Önceki, yarınki, dünkü, karşıki. And I think this is about some Persian words playing games with us. Sanayi, mevki, these are not, right? Turkish. But these are, again, we cannot define finite state rules for birer, ikişer, 50'şer. Okay, they are different. I cannot put them into the. So they found six exceptions out of those. These, I mean, depending on how you formalize your Turkish, okay. For some formalisms, these are not exceptions. These are within the rules. For some formalisms, these are the exceptions. Again, nobody designed Turkish. They did not define any rules for Turkish. We just use it. It's a natural thing for us to use. It is the task of the linguistic scientists or the computational linguistic people to come up with the set of rules for Turkish. What did we say about English? They said that somebody put together a 900 pages of English grammar, okay? I mean, this is just for morphology, not for the grammar. 900 pages of English grammar rules. Still, there are 5% exceptions, okay? What does that say? I cannot formalize the whole language using a set of rules. It's a natural thing. I cannot formalize them. It's like again, I am going to give the same example. You cannot formalize, you cannot analytically define how objects move for all the things in this universe, okay? F equals ma is maybe good, approximately good for intermediately large objects, okay? But for very small objects like the quantum particles, it doesn't work. For very large objects, for the galaxy, it doesn't work, okay? So I cannot explain the motion of the things in this universe using a single formula, but F equals ma plus the two other rules are good enough for many practical reasons. And we are going to do the same thing. I have only I only have 6 exceptions, okay? For the rest, I can explain the 90% of the whole language, I can say that. Okay, so we already looked at those, some of the example outputs of the system. And if we go to this, yeah, where did it go? No, okay, here it is. Remember we said çocukları, I think we had 4 different meanings. I think this one, plural third person, çocukları, onların çocukları, their children, right? This is their children, right? Is that true? Their children, and this is show me the children, çocukları göster. This one, his or her children. This one, aren't these the same? So obviously this is not working very well.
I think the first one was his children. The third one, their child.
But to put third, oh, okay, this is singular, right? Yeah. His children, this is their children.
Their child and
this is the children, this is children. And this one is?
Their children.
Their children. How about this one? Çocuk. Third, plural and çocuk. Well, this one doesn't work very well, as I said, okay? This may not be a valid morphological part of it. And this one says that every noun becomes a verb. So it is making a verb out of a noun. But çocukları, we don't use çocukları as a verb anywhere. And once you become a verb, you can put all kinds of stuff at the end of it. So the rest of them will not be valid. Okay, go back to the slides. Alınmış is it is both ambiguous in terms of the root word, alın, and alın, offend, right? This is noun alın, forehead alın, this is offending alın, okay? And this is red alın. This one is interesting too, boynu. Her neck, his neck, or neck, right? Boynu, boynu uzun. Is that what? Is that third person possessive? Her neck. Onun boynu uzun. Boynu gösterin. Okay, this one is accusative one. Anyways, do I have anything to say after those for the conclusions? Yeah. We did this all together and it is working. It is fast. Finite state machines are done using this PS chemo thing. It's a very old software environment. We don't have it anymore. We have much better tools than this. But basically, that's the whole finite state model for the language, Turkish language. More complicated than, as I said. Maybe this part is, okay, where is it? This first 22 rules, orthographic, morphological rules, maybe they are as complicated as English, because in English we have these kind of rules too. English has maybe 10 of them, Turkish has 22 of them. Okay, good. Any questions about morphology? Questions? If there are no questions, then I will start our new chapter. You might think that after the morphology, we are going to start talking about syntax, then semantics, and it go that way. No, we are going to take a shortcut. Okay, we are going to take a shortcut. We are going to tell you that, maybe if we think outside of the box, maybe ignoring this morphology, then syntax, then semantics, then pragmatics and discourse, etc. Maybe there is a better way of modeling a language, okay? We are going to model a language statistically, statistical language modeling, and this one will ignore all the syntax and semantics and discourse and etc. It says that everything is about statistics, okay? Everything is about statistics. Doesn't matter, okay? Doesn't matter. Okay, let's say I am a person. I am doing investment at the Istanbul Borsası. Okay, I need to model the movement of the Turkish lira against dollar and the euro and etc. I can come up with a very complicated model. Let's say that I will read all the news using natural language processing. I will look at all the economic data. I will look at the historical data and etc. And I will tell you that if today the Turkish lira will gain value or lose value and etc. Some other people say that okay, we don't need it. I just look at the movement of the Turkish lira in the last 7 days. Whatever the movement, and today is going to be the same. It's not going to change. So this is a statistical approach, and most of the time statistical approaches work better than very complicated analytical approaches. That's what we are going to do with the statistics in language. And we are going to do stuff like, what is the probability of saying, I read books? Okay? If I can measure the probability of I read books, okay, if it is high, I can say that this sentence is a nice sentence in terms of syntax, semantics, pragmatics, and etc. And I will ignore everything else, including the morphology too. Okay? And we are going to find that using very simple statistical analysis, we are going to find that this will be higher than that. I read book, I reads book. Okay? We will never say that the probability of this sentence is going to be 0. Okay? But we are going to observe that probability of having this sentence is higher than that. Okay? That's the probability. Everything has some kind of a non-zero probability. That's one of the rules. So Why is this useful? Imagine that I am doing Turkish to English translation. Ben kitap okurum. Okay. Would I translate it this way or that way? Okay. And probability of this sentence is higher. So I'm going to choose this one. It's a very convenient way of making sure that I am producing something meaningful in terms of syntax and semantics. Or I can measure this. Find me this. Arc max x p I comma x comma books. Okay. Scan all the words in my dictionary, okay, to make this probability largest. What would be the value of x? Okay. So most probably it's going to be I read books, maybe I sell books, I carry books, but it won't be I run books, or it won't be I walk books, right? So or maybe I walk books has a higher probability than I pen book. Pen is a word, right? I table books, right? So I'm trying to find a word that is not taken as a verb, right? So, so it is capturing both syntax and semantics. It says that I walk books has a much smaller probability than I read books. Okay, so semantic wise, it is saying something. Okay, when I say I good books, okay, compared to I read books, good is good is an adjective, read is a verb. So it knows about the syntax too, right? So it knows about syntax, it knows about semantics, it knows about morphology. So this is a very convenient way of representing all levels of linguistics. Okay, that's what we are going to do. We are going to use semantics to give us these probabilities back. Okay, and you might say that it's going to be something complicated. No, it is not going to be complicated. It will be very, very simple. And in fact, I am not going to use anything more complicated than this slide, and this slide you already know. Conditional probability, you already know that, right? What is Bayes' theorem is a definition. It's not proven, it's a definition. Given that I know B has happened, what is the probability of A? Okay, it's the same thing as multiply probability of A being happened, then multiply this, given that I know A is true, probability of B, and divide it by PB. And sometimes people say that PA given B times PB is equal to just PBA, PA. And both of them, okay, is equal to, they are both happening at the same time, PAB. Okay? We already know this from our middle school years. So how are we going to use this for the words? I can say a funny thing here, okay? What is the probability of seeing this word ben in Turkish? Well, the very funny question, but it's a question. So what is the probability of seeing this word ben? So where do you want to see this word? Well, what is the probability of seeing this word ben on the web? Well, you can say that how many times ben happens on the web. So for that one, I just type ben. It says that ben happens more than 4 billion times. Is this billion? Yeah, it's billion, right? It happens 4 billion times on the web. How many Turkish words are there on the web? Maybe 1 million times more than this word. So it's going to be 1 trillion, 1 quadrillion. I don't know what it is, okay? So the probability of seeing Ben on the web is, okay, is going to be as simple as this is 4 times 10 to the 9, right? So how many words there are on the web Turkish verbs? Let's say it is maybe this much. So that's the probability, very small probability, but it's a probability. And I bet it's going to be larger than, okay, seeing a rare word. Tell me a rare word. What was the word that you told me during the break? Your mother told you? Angela? Well, it happens, okay. It happens only 4 times 10 to the power 5, right? Is that true? So it's going to be more than P Angela. It means famous. Okay, it's going to be 4 times 10 to the 5, 4 times 10 to the 18. Okay, so I can measure the probabilities of these kind of words. Well, if I can measure the probabilities of these words, how come I cannot measure, okay, ben geldim? How am I gonna measure this, the probability, okay? Well, it's the same thing again, just type it there. How many times it happened? Ben geldim. Ben geldim happened only like 1 million times, okay? 1 million times on the web. So how many word pairs on the web? How many word pairs? Like any word coming after the other. For example, ben geldim, abone olmak için tıklayın. Okay? Kadıköy Halk Eğitim, Eğitim Merkezi, Merkezi abone. These are all word pairs, right? How many word pairs are on the web? Turkish word pairs is going to be 10 to the power, not 18 this time. It's going to be 10 to the power 20, right? Because I am taking this square of it. Very large number of it. But still I can measure the probability of that sentence ben geldim, right? So this is basically it. You just count the number of occurrences and you say that this is happening more than that one. This is happening more than that one. But how about this one then? How about ben sabah koşarak okula geldim? How many times this happened? Well, it did not happen at all. Nobody said ben sabah koşarak okula geldim on the web. Does that mean that the probability of this sentence happening is 0? Well, if I say it is 0, well, it's a perfectly valid Turkish sentence, right? I mean, can you imagine how large this Turkish web is? I mean, 20 million people every day, they are contributing some sentences, Turkish sentences to web. Okay, even though everybody is contributing to it, it looks like nobody has said anything about this sentence. Ben sabah koşarak okula geldim. Maybe ben sabah koşarak geldim. No, ben koşarak geldim. Yeah, it happened. Only, but this is very, very small. 323 times, very small number. So our problem here is this. Even a sentence as simple as small as ben sabah koşarak okula geldim. Even the sentence is so small, I cannot find examples on the web. So our method of measuring the probability that way is not going to work, okay? Count it and take this probability and this is your probability. Is not going to work. We have to do something else. And that will be the main thing in this chapter, what we are going to do, how we are going to measure it. And it's going to be a very simple idea again, okay? And that will be our language model. Once we do this language model, okay, we are going to use the same language model to produce sentences, okay? Produce me a probable sentence Turkish sentence, and it's going to produce something for us, or English. It's going to produce something else. Or sometimes we are going to say, okay, it's not the English that I want you to learn. Just take the statistics of Linux code, okay, in C. After you observe it, produce me some C code, and it's going to produce some C code, because it is just as simple as taking the statistics. Okay, any questions so far? I did not say much about the main techniques that we are going to use, but this is the general introduction to this chapter. Did everybody sign the attendance sheet? Everybody? Okay, let's take some break. After the break, we will continue. 10 minutes.
kelimesinde.
Evet.
Onları hiç hesaba katmıyor muyuz yoksa iki ayrı
Katamazsın ki, elinde sadece bir kelime var. Ben sana çocuklarını verdim. Ne yapacaksın?
iki ayrı state varmış gibi iki tane böyle biri bir yere çıkıyor, biri başka bir yere çıkıyor gibi ve düşünüp daha sonra semantikte ve
Evet. Aha. Diyeceğiz ki elinde bu 4 tane farklı mana var. Hepsi olabilir. Bunlardan hangisi olacağını ileride genelde sintaks çözüyor onu, tamam mı? Sintaks çözüyor genelde. Yani diyor bu olamaz diyor, çocuklarının bu manası burada olmaz diyor. Çünkü birisinden yani ihale varsa çocukları gördüm, tamam mı? O zaman anlıyorsun ki çocukları gördüm. Yani Ahmet Bey'in çocukları gördüm olmuyor. Çocuklarını gördüm olur o. Tamam mı? Çocukları gördüm deyince ha tamam diyorsun, bu ihale olana.
ama hepsi ayrı ayrı yerde ve önce bir düşünüyor.
Evet. Hani morfolojide ambiguity nasıl çözülür vardı ya, hani daha sonra çözerler, beklersin. Bazen onların hiçbiri yeterli olmuyor. Manaya bakman gerekiyor. Bazen de olduğu gibi bırakıyorsun öyle, yani iki manaya da gelebilir oluyor. Şiirlerde falan öyle yaparlar mesela. O da oluyor, o da oluyor. Okay, let's continue. So these are our stuff. We already know this biased rule. Pn and Pb are independent probabilities of A and B happening. This one says that after, okay, this one is something like this. What is the probability of ban? Okay, I know that ban happened. I have seen this word ban, and this one gördüm. Okay, conditional probability. So you say that find all the occurrences of ban, find all the occurrences of gördüm, and find this one and multiply them, and you will get this one. These are the rules. Okay, so let's go back to the slides of the book. The book says, okay, if I ask you this question, I notice three guys standing on the, so what would be the most likely word that you can replace these three question marks? What should I say? I notice three guys standing on the what? Just give me a what?
Bench, for
Say. On the line, yeah, standing on the line, standing on the bench. Really? They are standing on the bench, standing on the sidewalk, maybe? Yeah. You are giving me some object names, which is nice. So you are using your semantic information, actually. I mean, three guys can stand on some kind of an object, right? Either it's a line, okay, bench or sidewalk or street or I don't know, the floor, etc. So you are using both your semantic knowledge and syntactic knowledge to make a decision. Nobody said, okay, I noticed three guys standing on the, for example, good, an adjective. Nobody said that because that would be against rules about the syntax of the language. I mean, on the good, standing on the good. I mean, I need a noun here, not an adjective. Or I don't say standing on the, for example, right. I can't put a verb in here because it needs to be a noun. Out of all the nouns, it has to be an object, right? I mean, for example, happiness is a noun, okay? Standing on the happiness is not going to work, okay? Because it has to be an object. So I need both common word knowledge. I need syntactic knowledge, semantic knowledge, and etc. to fill in this gap, okay? Or we can do simple statistics. If I know how to calculate the probability of, okay, I notice three guys standing on the good, I notice three guys standing on the sidewalk, just calculate the probabilities and choose the one that produces the largest probability. That is our language model. So it's going to be a probabilistic language model. So let's try to calculate that. Okay, let's go to calculate that probability. For that one, we are going to use n-grams, okay? N-grams means this. This is a 2 gram, I notice. Notice three guys standing, okay, or bigrams. So 2 gram means that, okay, 2 gram means that anything happening right after the other, that's a 2 gram. 1 gram means that just a one word, okay? How many times I notice happened in my corpora? How many times standing on happened, okay? If I put standing on here, because the English verb is much larger than Turkish verb, standing on, okay, it says 103 million, okay, times it happened standing on, okay, it happened that many times. So it is that lots of probability is happening with these 2 grams, okay. So given the knowledge of counts of n-grams such as these, we can guess likely next words in a sequence, maybe. But maybe, I mean, on the, it's okay, but after the, what's going to happen, I don't know. I mean, by just looking at those 2 words, 2 grams, it's not going to be, I forget what I said before. I mean, I notice three guys standing. Each one has a probability, but they are independent of each other. And when I say on the, after the div, what's going to happen, this something can be anything. I mean, I'm not including this probability of notice three guys thing in my calculation, and we are going to look at it. Okay, so more formally, we can use knowledge of the counts of n-grams to assess the conditional probability of the words, and pick the one that produces the highest probability is our main purpose, main target here. And this can be a very useful thing. Automatic speech recognition, okay, handwriting and character recognition, spelling correction, machine translation, and many more. And we are going to see these examples. So it's going to be counting thing. So we are going to count. But how we are going to count is going to be a little bit detailed, and we are going to, okay, we are going to see how we are going to get rid of the problems of these details. I'm going to skip these. Okay. When we count stuff, how we are going to count them is something different. Okay. I'm going to skip these two because, okay. Word form is something that we need to be careful here, because as we said before, for languages like English, word forms are not that many. I mean, with a noun like cat, how many variations, how many word forms can we have with a cat? Cat or cats, and that's it. Okay? Goose and geese, that's it. That's it. But for Turkish, we have kedi, we have kedinin, kediye, kediden, kedileri, etc. 5,000 different word forms of kedi. So when I say kedi gördüm, is the same as kediyi gördüm, kedini gördüm, kedileri gördüm, kediler gördüm, etc. Right? Are we going to count these 2 grams as a single 2 gram or different 2 grams? It's going to be a very difficult problem for Turkish. Not maybe for English. Well, English has the same problem, but the problem is not as severe as Turkish. Okay? So word form is fully inflected surface form. What we see on the surface as the inflected way. For cat, in English, we have only 2 forms. Okay? That we can think of, but for Turkish there are 5,000 different forms. Are we going to do this morphological analysis before we do the counting thing? Well, we have to delay. Some people say that, okay, Turkish, it is becoming a big problem. So what are we gonna do? Maybe if I have a word with, okay, this many letters, maybe just take the first 5 letters of it, ignore the rest, and count this word as a word. Ignore the suffixes. Some people say that. Other people say that let's do the morphological analysis and do the counting, but Morphological analysis, remember this one? Remember our, okay. Morphological analysis doesn't give you the root word all the time. Remember that allen thing? Okay. Sometimes the root becomes al, sometimes root becomes allen. Okay. I don't know which one it is without doing the morphological disambiguation. So this is going to be a problem. Let's ignore this problem for Turkish or ignore the problem for English for now. Well, ignoring it for English, it's going to be easier because it's not a big problem. But Turkish is going to be a big problem counting word forms. Okay, so let's try to see how many unique words, okay, how many unique words we have or word forms we have. In brown corpora means that just a data set of words, okay? So brown corpora is one large corpora that was put together in 1992, okay? It was a very big one for that date, okay? 500 or 600 million word form tokens, okay? So there are almost 600 million word forms, but total number of unique words is almost 300,000. Google says that, okay? I have scanned all the English documents, and I already know all the words of the web, okay? And I have this many tokens, this many words. I don't know, this is million, billion, trillion, and what is it? Quadrillion? I don't know what it is. So it is 6, 12, 10 to the power 12, something like that, okay, words. And out of them, I have only 13 million unique words, word form types. So you would expect that, I mean, the number of words you have is going to be proportional to the number of words in a dictionary, but no. I mean, in a dictionary, you have only the words and maybe some of the large of the whole word, but in this Google word forms, you have the numbers, you have the misspellings, you have the names. Okay, in a dictionary, you don't have the names, right? You don't have the names of the people, especially on the web. You have many names, acronyms, and etc. So total of 13 million word form types. So Google knows in a 13 million dimensional, okay, in an array of one dimension of size 13 million, let's say this is the word book. Google knows that maybe a book happened, okay, 10,000 times. Maybe for mine will happen maybe 5,000 times. So for all of these 13 million entries, it knows how many times it occurred. Google also knows in a matrix format 13 million by 13 million, okay, how many times I read has occurred, I and read together, okay? It says that it occurred 2,000 times maybe. Okay, it knows it, okay? Google knows all the 2 grams, how many times those 2 grams occurred, and Google says that it can go up to 5 grams. 5 grams, okay? So it can count all the 5 grams, and it can tell you those, and they made it into a nice website, Google Ngram. Go to Google Ngram Viewer, and nice thing is it remembers everything. So let me do this. Albert Einstein do this, and it says that, okay, between 1800, this is 1800, to 2019, Albert Einstein happened this many percent, very, very small percent, but it looks like in 2008 it made a peak, later it dropped. So out of all the 2 grams that were used in 1921, 0.00000522226 is Albert Einstein. Okay? And we can say things like, I can, okay, Turgut Özal, put it in there, and, well, it is, I have used the Turkish character, run it again. So it looks like the peak was 1989, 90, then it dropped and it dropped. So nowadays it's happening, but it is dropping. Okay, so these are the 2 grams. Let's do this. Okay, white hat hacker trigram. Did I hacker is okay? Did I spell something wrong? White hat hacker. Oh. You don't put the quotations right. Yeah. So somebody started using this in 1996-7. This is getting larger and larger and larger. We don't believe what it says around 2019. The statistics are wrong. Okay. So white hat hacker, just give me a bad. It never happened. This 4 gram did not happen. Okay. Just tell me white hat hackers are, how many times did it happen? Yeah, okay. So it is, so this 4 gram is there, are good, are nice, no, are many. How come nobody used these? But the thing is that if this does not happen more than 40 times, Google doesn't include it as a statistics. Okay, it has to happen at least 40 times. I don't know. I mean, after that, what people are saying, I don't know. But Google says that I collected all those 5 grams, and they are all there, and I will give you all these statistics. And so it is like the terabytes of data, I guess. If you like to download it, you will have, okay, this is a matrix, right? It's a 1 million by 1 million matrix. So how many entries are there? 1 million by 1 million. So 1 million times 1 million is going to be 10 to the power 12, right? So how about 5 grams? It is 30 million times 30 million times 30. So 30 million to the power 5 is going to be a very, very large number. Google keeps it, okay? And it keeps it with the dates and everything, okay? So they have it, but still, when I say white hat hackers are good, it says that I couldn't find it. So what are we gonna do? Are we gonna say that the probability of having such a sentence is 0? That doesn't make any sense. It's a very simple sentence, a grammatically valid sentence. And it can happen, and I am trying to pick something that is very possible. It says that I didn't see it, so we have to find a way to deal with this problem, and that's coming in a few minutes. Okay, so language modeling is this. Back to word prediction, we are going to do this. Given the first n minus 1 words of a sentence, okay, predict what would be the next word is. Okay, that's the word prediction problem. And if you can do this, you are kind of modeling your language. Okay, what it needn't say that I'm going to define you 3 rules. Okay, for the object motion 1, 2, 3, and for the third one it said F is equal to ma. For the second one it say that if an object moves, to stop it, okay, you need some kind of a force. If an object is stationary, to move it, you need a force, okay? So he produced a number of rules, and he gave us some closed form analytical formulas, and we can use them. This one says that, okay, you give me beginning of a sentence, I am going to tell you which one may come next. So we are using this formalism, this model, to guess how the objects are going to move, and we are going to use this model to guess how the words will come after these. Okay, and that's going to be a language model. The previously, what I showed you at the beginning of the semester, we do the morphological analysis and the syntactic analysis and the semantic analysis and etc. It's trying to produce a model of the language, and it is using very analytical stuff, but this one uses just statistics. It doesn't care about the syntax, morphology, semantics. It says that all I know is the statistics. Okay? So the same thing. How are we going to calculate, okay? After this sentence, okay, this group of words, its water is so transparent that, what is the probability of seeing a "the" after that? Okay, to measure it, okay, our base formula says that you need to calculate this. So on Google, type it, its water is so transparent that, okay. So the count the number of this one happening, and the counter of number of this one happening, and make this division. It will give you the probability of the given its water is so transparent. But when you type this to Google, okay, both of them will come back as 0. It says that Google, nobody said this, or it says so. Let me try to. Can I do this? Can I do this? Okay, let me type it in here. It's going to be is water is so transparent that, if I put this in quotes, how many times do you think it will happen? How many? Well, usually it's a 0 because, okay, it says 3,700 times, but look at where they are coming from. Okay, these are all the slides of this book. See, so nobody's using it actually. So it is never used. Nobody used it. So how am I going to calculate that? And so its water is so, instead of transparent, let's say cold. Okay. Well, it's water. So it happened many times. So it is so mild. Never happened. Okay. So Google, with its of terabytes of data, say that no, nobody has such a thing. It says so. Okay, but I don't like it. I don't, because if I am going to base my calculation based on this, okay, it's not going to work. It's not going to work. So I have to come up with a way of doing that, and so it's going to be 0 or 0. That's going to be a bad. Let's find a solution. Solution is the chain rule. Okay, you guys remember this rule? If you are going to calculate the probability of all of these things happening together, then you do this: probability of x1 happening, then given x1 probability of x2 happening, given an x1, x2 probability of x3 being happening. Okay, you multiply all of them together, and it will give you this probability. Again, this is by the definition of the. This is by the, remember this one. P. Or maybe I should go to the beginning. This is 18, slide number 1. Slide number 1. Remember this? Okay. PAB can be written as PB times given B probability of A, right? But if I take this, okay, if I take, why don't I use it in a, okay, P, A, B happening together is PA times P, B, A, right? Okay. What if I replace A with two things, okay? How about, okay, instead of A, just type P, A1, comma, A2, B. It's going to be P, A1 and A2 times P, B, A1, A2. Well, this one is same as this. Then I can do this then. P, A1 times P, A2, A1, then P, B, A1, A2. See, I can, if I replace A1 with two other things, I can go on and on and on, right? So that's where it comes from. 18, right? Yeah. Okay, so this is where it comes from. If you are going to calculate this probability, then if you calculate each of them one by one, then multiply them, you are going to get this number P, x1 to xn. So I can get this P. What was the Turkish sentence that I told you that never happened on the web? Ben okula koşarak gittim. Ben, okula koşarak gittim. So you are going to say, okay, probability of Ben, I know it happened. Probability of times, probability of given Ben okula, right? And then ben okula koşarak, etc. And at the end, I am going to say probability of gittim ben okula koşarak. Okay. So what is the good thing about this? I can calculate the probability of Ben because I know it happened many times. I can calculate ben okula too because I can type it. I hope it happened. Okay. Ben okul. Yeah, it happened 200 times, 200,000 times. Okay. I can do that too. But how about ben okula koşarak? How many times do you think this happened? Guess, any guesses? Ben okula koşarak? 7. It happens 7 times. Well, very weak statistics, but okay. Weak statistics, but it is still better than 0. But I am not going to get anything ben okula koşarak gittim. Okay? It's not.
Ben işe koşarak gittim.
Maybe what this is ben okula koşarak gittim, right? I mean, this is what we are going to. So, this chain rule kind of solves this problem for this one, but when I hit this one, it is no it is no different than the original problem itself. So what are we going to do? We are going to do this. Okay, basically, any probability like this can be written P its water, given its water was, etc. I can calculate this one, this one, this one. I'm going to have trouble with this one and this one. So what are we going to do? We are going to do this independence assumption. Okay, independence assumption. We say that. Okay, let's try to calculate the possibility of seeing a lizard. The other day I was walking alone and I saw After this, what is the probability of having a lizard? Okay. Somebody says that, well, this probability and this probability is almost the same. After seeing saw a lizard, okay, after seeing saw a probability of seeing lizard is almost the same as the other day I was walking alone and I saw a lizard, okay? So why do I have to list all of these? Because these are kind of independent for me. The important thing is that after saw a, okay, I am talking about seeing a lizard. Okay, so the probability of in question is independent of its earlier history. I am going to ignore whatever I have observed before. I am going to look at only final 2 words of it. Okay, final 2 words of it, or even final word of it, a. Okay, so it's going to be maybe an approximation, and that's what we are going to do. We are going to say that, okay, I can calculate this. I am going to get rid of this one, and I'm going to get rid of this one. Okay, so this is going to be, is water so? Given is water, what is the probability of so? Okay, and no, I did it wrong, right? I am going to get rid of this one. After given what water was, what is the probability of seeing so? And after that, given was so, the probability of seeing transparent. So it's going to be a 3 gram, 3 gram, 3 gram, 2 gram, and 1 gram. Okay? So it's going to be an approximation. It's going to be an approximation. And that approximation is due to Markov. Okay? Markov approximation. Okay? Andrei Markov, Russian mathematician of 19th century maybe. Okay? He said that if you have dependent observations, okay, if you have dependent observations, and if you are in a bad situation where you cannot calculate the statistics of all the whole data, then ignore your history, only remember the last 2, 3 observations. It's like this. Okay, in this month, today is 24th, right? October. Starting from the first day, October 1st, it rained, second rained, sunny, sunny, cloudy, cloudy, rain, rain, cloudy, up to 24th, okay? Then we have rain, rain, cloudy, cloudy, sunny, and rain, let's say. What's going to happen tomorrow on this is 24 and 25th. What's going to happen tomorrow? To guess it, maybe I can put together all of my observations of the last 100 years of Gebze, okay? See if any of this pattern has happened before. Probably it never happened in the last 100 years. For the last 24 days, I'm not going to see anything like this because it's a very small probability, right? But if I ignore these, and if I see how many times cloudy, cloudy, sunny rain happened, okay, count it, and how many times after this pattern I see a sunny, I see a rainy, I see a cloudy, I say that, okay, sunny happened most often, then I am going to say tomorrow is going to be a sunny. Okay? If I had never seen such 4 days, one after other, then I can ignore one more. I can ignore one more. Okay? Just look at the last 3 days. That's what this Markov says. Okay? In a sequence of observation like those, if you are in a difficult situation, just ignore your history and only remember the last few instances of it. Of course, it would have been better if I can remember all of them, but if you remember them, I will not get enough statistics. That's the Markov assumption. Okay? That's the Markov assumption. And Markov, of course, this guy didn't know anything about natural language processing. Okay? This guy didn't know anything about, by the way, this is Andrei Markov of NHL. He plays for, where? I don't know what this is, CH. I'm not very good about ice hockey. So this guy has nothing to do with mathematics or NLP. This is our guy. Okay, old Russian times, Russian Empire times. Okay, he said that you can ignore these observations of the old days and just keep a few days. Okay, that's the Markov assumption though. So this is the assumption. Okay, so if you like to calculate the probability of this one, instead of getting the words from 1 to n minus 1, get the words from n minus capital N plus 1 to n minus 1. What is this n? This one is our 2 gram or 3 gram or 4 gram, whatever value we have in our database. Okay? So for bigram version, it says that just remember the last word only. Remember the last word only. Okay? So now we have a nice way of calculating the probability of a given sentence. Doesn't matter if the sentence is 100 words long. Okay? Since we are going to multiply all these bigrams one by one because of this assumption. Well, I mean, you might say that this is an approximation. Yeah, that's true, but it's a very nice assumption. And it holds its value. And the nice thing is that we are not after calculating the exact value of these p's. Okay? We are after comparing these p's. Right? We are going to compare them. All of these p calculations will do the same assumption. So I'm going to keep them comparable. They will be different from 0, and they will be comparable values. That's what makes this counting stuff so desirable, so convenient. It is mathematically sound. Whatever I am assumption making, it is based on some kind of old theory, and it works very nicely. And as you are going to see, it will be okay. Okay, good. Any questions so far? I am out of time for this week. I will stop at this point, and tomorrow, well, not tomorrow, next week, we will continue from this point on. I assigned your first homework, which is not that difficult, okay? You are going to implement some minimum edit distance, okay? And I am writing your second homework too. It will be about minimum edit distance, but this time it's going to use word vectors, okay? The first homework doesn't use word vectors at all. Okay, see you next week.